Alteryx is a great data management tool. What it is not is a database management tool. So if you're entering into your self-service for analytics and you're creating objects in a database, you will also be required to clean up those objects, make those objects more performant, as well as to deal with some of the peculiarities of how Alteryx interfaces into databases. From an earlier video that I'd done, you had seen that Alteryx determines which objects and how to create objects, columns, and indexes for you, and doesn't give you the ability to control what it does. So to do that, you have to go directly to the database itself. So we're going to talk about some of the basic commands in the SQL language that will help you as you manage the objects that you are creating with Alteryx. More specifically, we're going to talk about the basic of just simply dropping tables, how and when you need to create a table, some management of tables. We'll talk a bit about managing your views, and then finally I will show you a quick app that allows a little bit of management of objects so you can see how Alteryx does provide you with some options for managing your objects, but you have to know how to do it so that you can embed that SQL language statements into your Alteryx widgets. So let's get started with the basics. I am in my MySQL workbench. These are my Daisy Hill tables. I've created a few tables to work in this module with. One that we'll be creating later, so I can just go ahead and remove it now, which happens to be a second copy of my puppydim. Over here, the puppydim_WIP work in progress is an object that I created that I just right now want to get rid of because I no longer need it. So to manage this, I simply want to drop it. Alteryx does not have a drop table widget. So a couple of ways that I can do this, and we'll walk you through each of the three. One is I can simply right click on this table, and I have the option right here to drop the table. There's absolutely nothing wrong with this method of managing your tables. What it does is brings up this little warning that says I can drop the table for you, or maybe you would like to see the SQL. Well, let's take a look at the SQL. As you can see, the command that it will be executing is simply a drop table statement. And you can see here that Alteryx MySQL likes to put these backwards quotes around all of its objects names, which just sort of irritates me and is not really necessary. Keeping that in mind, you can now just go ahead and execute this here. We'll drop the table. We won't do that. Or if you like, you can simply type in the drop table command. As you can see, as you type in the command, it color codes those words that it knows, so you can sort of get it does a ongoing syntax check. And my table is in a Daisy Hill schema, a period, brings up the list of tables that are in here. I can begin to type in the name. There's my object. I can execute it. I get down here at the very bottom, recognition that the command executed successfully, and it just simply says no rows affected because it wasn't a query or an update. So now that table is not there, you notice that it's still actually I took it out if you saw me run it. Sometimes the actions that you take here in this screen do not immediately appear inside of your schema navigator, and then you would simply want to do a refresh to get the most current copy of it. Following along these lines, let's go ahead and take a look at this puppy dimension table and how Alteryx created it. And to do that, we can right click on the puppy dimension. We can do a sending to the SQL editor. We want to send a create statement, so it will actually give us the create statement that is used to create this table from a native database standpoint. It has a lot of things in here that you don't need or do need, but what we don't like in this table is the fact that the birth date is a date time. This is because when Alteryx moved my date type into MySQL, it created as a date time. MySQL does have a date attribute type, and that's really what I want to do. So what I can do is take and cut this out of this editing window, and I can go ahead and make a much simpler version of this through my favorite editor. And then I simply have a create table to create a second copy of this. I've removed a lot of the noise around here. I removed the backwards single quotes. But most importantly, the birth date is now actually a date. When I execute this, very quickly down the bottom, you can see that the create table statement has executed. And again, it did not appear over here. So I hit my refresh button. And then here is the table. Click on it and you can see that the birth date is actually a date and no longer a date time. This is very good. It's how I like to see this data. It makes it more useful as well as more accurate. What I need to do now is move the data from the puppydim into this work in progress table. I can do that a number of ways. But again, since Alteryx is my data management tool, I can go ahead and create a very straightforward, simple Alteryx workflow that reads in the puppy dimension and writes out my work in progress table. Because I do not want Alteryx to modify this table, simply use it as it exists, I chose the option in the outputs of delete data and append. What that means is it will delete any existing data and append the new data into it. I could also have chosen append existing, but I just want to make sure it's nice and clean and works in all situations. Having done that, when I execute this, it'll go ahead and move the data over for me. So once that is completed, I can go back to my workspace and do a select star from my just created puppy dimension work in progress table, execute this, and you can see that the data is there and the birth date is now indeed just a birth. We also added an additional column called puppy sex, and since the date did not exist in my workflow, it turns up as all nulls. So this is how I can add columns and modify columns and change the definition of this data as I need to. Now, in case you're playing along with this process and you've been through some of my other videos, I have discussed the fact that the performance of inserting records from Alteryx on my local machine into Amazon Web Services RDS environment is a bit slow. I've done some research, looked at a little bit of performance, did some manipulation of what's available to me in Alteryx, and have not come up to a solution. But what I believe and I have seen is that the data has to do with the upload speed of records into the AWS cloud environment, and in order to improve that would probably require some actions on my part as far as building a better channel, more space, better I/O, something that I'm not just really ready to do. And one of the ways that I prove this performance is by using a second mechanism to actually copy my data that does not require the data to come down into my Alteryx workflow, but instead relies simply upon the in-database widgets. Again, I am not a big proponent of the in-database, but this is a place that it really seems to shine because it relieves your local machine of just simply copying data from one table to another table. So what I did is created my connection to the invoice fact table, verified that the names were correctly with a select, and then I simply wrote that data out. Creating new table assumes that the NDB doesn't exist. And so I can check very quickly and see that the NDB does exist. So before this runs, I can right click on this, click on drop table, drop now, table's gone. So this is how you can manage the data. I also could have changed the methodology, but what's the fun in that? So now when I run this whole process will run strictly on the database with nothing involved in my local workstation. There'll be no uploads or downloads of data. Click the run. And you can see that the database itself is very fast and efficient. Verify that the table got created. go back to my workbench, hit the refresh. You see that NDB is here, and I can go ahead and do a select star from the NDB table, drag and dropping the name of the table in, and there's the data. Very quick, very efficient manner to go ahead and make a copy of a table, move the data into that copy rather than having to do some mass manipulations, as well as to control how that table is created. So let's look at some of the other tasks that you might need to do within your database. One of the things that is always very important is understanding what your tables and columns are. And to do that, typically you add comments into database. I am, again, not a big proponent of adding comments and tables and columns in your database because people don't always know how to look at them there. If you really want to get into some kind of extensive documentation, I recommend that you manage a metadata table very simply, and you can use Alteryx for that, and your favorite BI tool such as Tableau to present that data. But just to round it out and see what you can do, what I have found is that Alteryx, not Alteryx, but MySQL has one of the least friendly methods for managing comments on tables, which sort of reaffirms my point of not doing it within the database. Other databases have other facilities to add comments and manage comments that is much easier than what MySQL, at least the community version, does. And so that is why I would sort of refrain from doing this. But to round it out, in order to add a comment on a table, I would alter the table, in this case puppy fact, and I would simply add a comment afterwards, putting it in single quotes. I execute that, and you can see that it went ahead and worked fine. Question always becomes, once you've done that, how do you see the comments? Well, it is in your information schema. So that's why it's a little bit harder to find, because not only have you created it, you have to tell someone how to find the comments, which means they have to know how to query the database, or you have to write a workflow and or a Tableau. So you, again, managing yourself is not a bad idea. So here we go ahead and we select table name and table comment from the information schema tables. And I'm just choosing to just be the table schema Daisy Hill. And you can see that here are all the tables that are in Daisy Hill. And we have the comment for the puppy fact table. Adding comments to columns in the table is even harder to do within MySQL. Again, some RDBMSs make this easy, MySQL doesn't. In this case, what I have to do is alter the table. So I execute my alter table statement, puppy fact, and instead what I want to do is modify each of the columns in order to add a comment. The problem becomes is that I cannot just simply modify this column and add a comment. I must repeat the entire definition of that column as I need it to be. So in this case, these are the existing parameters for those columns, and I simply added the comment to the end of that existing one. Again, this is nowhere near the most friendly method of doing it, but if you have to, this is how you would do it. We see that executed cleanly. Question always becomes, how do you see those comments? Well, you could query in for the information schema and look at the columns table, which I might as well go ahead and show you. So I select a column name and the column comments from the information schema columns where the table name equals puppy fact. Again, there's a lot to go on in learning to write this query, which is part of this class as well. So this is the way I would query it out of there. For some reason, even though you do not have a shortcut for showing you the comments for a table, you do have a shortcut for showing you comments as well as other information with the show full columns command. This is a non-standard SQL command. It is simply a specific one that is available to you within MySQL. In this case, it'll show you your columns, other information about the columns, and fortunately way out here at the end happens to be our comments. So that's how I can see them. Metadata is a whole nother topic, one that I've had many times with many companies that I've worked for and with people that I've worked with or that I've known through my network. If you have any metadata questions, issues, or want some ideas, go ahead and subscribe to the channel, drop me a comment, and I will respond back to you and do something or set something up that might specifically address your needs. Okay, so continuing on outside of that little blurb, one of the other things we need to do is also, if you notice, we have no primary keys, and we talked about how a primary key constraint can be used. It also creates cleaner access as well as some other good things in your database. I recommend creating primary keys, and since Alteryx does not create a primary key and MySQL does not generate one by default either, we need to understand how to create that primary key. It's pretty simple. It's still in the alter table SQL statement. Again, this is the actual command, which is alter. The object is table. There's the table name. And what we want to do is add a primary key, and then in parentheses we give it the column or columns that are a primary key. If you've seen some of my other videos, I've actually created a macro that does this automatically for me. But before I could write that macro, I had to understand how to create that command, test it, and verify that it works. And we can do that right here. Runs very quickly, tells us that there were no errors or issues associated with creating that primary key index. And if I clicked on the name of the puppy dimension whip right here, after hitting refresh, sorry about the refresh part, there we go. And you can see that widget now has PK next to it because it's been identified as a primary key in this table that we created. So I know that was successfully created there. Again, managing primary keys, very important, gives you better access, better control, as well as better documentation. We also talked about foreign keys, which are how you identify the reference from one column in one table to the primary key into another table. It helps you manage your data, make sure that no bad data gets put in there. It also helps with documentation within the database. And in most databases, it also adds an index that improves performance of querying between those two tables. All good things to do. If you have a stable data store that you want to manage, I recommend that you add your foreign keys to show that reference for a number of reasons. But essentially, it still is the alter table command. In this case, we're going to alter the table puppy fact. We're going to add a foreign key. This is the column inside of puppy fact that is the referencing column. So puppy wid is inside of the puppy fact table. It references the table that contains a primary key. So in this case, it references the puppy dimension. The puppy dimension has a primary key defined as its wid. So therefore, what we're doing here is establishing a relationship to whereby the values in puppy wid and puppy fact must exist in the wid column within puppy dimension. We execute this, and you see down here as well, it tells us that it executed successfully. So it validated that all the data was clean and ready to go. We hit the refresh button here as well. We come down to our puppy fact table. And that we want to do here is expand out and look at foreign keys. You can see that there is indeed a foreign key that was created. This is the name that was given by the database. And it says that the target of that foreign key is a puppy dimension, where the local puppy wid column references the wid column within that dimension table. One of the other things Alteryx does not do very well as far as data management is concerned, and that is in deleting your data. There's a couple ways that you can delete your data. If you notice we have data under puppy wid, the very basic one is simply to truncate the data. Very quick way of removing the rows from within the table as opposed to a delete. You see that truncate is a known reserved word, so we want to truncate table, give it the name. We're going to go ahead and do from the data from the table that we just created. execute this. It's a very quick and clean way of getting rid of that data. It also frees up database space as opposed to a delete. And so we want to verify that data is indeed gone. We can do a select star from the puppy dimension. And you can see that no data was returned, so the data very quickly went away. We also can delete the data, giving it a where clause. In this case, what we do is a delete from the name of the table, where a column has a value, or any other predicates that you need to identify which data needs to be deleted out of that table. Slight warning, if you try to do this and you have not changed any options within your MySQL database, you'll get an error that says that you are in safe mode. You need to take yourself out of safe mode. The option is under Edit, Preferences, inside of your preferences, choose the SQL editor. Down the bottom, you see that it says Safe Updates, rejects updates and deletes with no restrictions. That's not quite true. What it does is restricts any updates or deletes that do not involve the primary key column, which is a bit different as well as much more troublesome. You will want to click that box off because by default it is clicked on. Once you've done that, you need to close your connection to the database. I would go ahead and work my way all the way out of the workbench and come back into the workbench, because this change will not take effect until you have basically restarted your application. Once you have done that, then you can go ahead and do a delete such as this from the MySQL Workbench tool. So essentially now when I execute this, it'll very quickly delete the records that I had out there, and it will show me that there were 215 rows that were actually deleted from that table. So that is how I can go ahead and delete records out of it. Now there's also a way that you can manage this data once you're trying to do some deleting data, because a lot of times you don't want all of the data to exist within your table. So in this case, I have a quick little utility that manages a customer invoice, the costume invoice table to work with. This one has a lot of data. If we look at the data, this is actually two pieces. Put it together. The very first part is put inside of a tool container, and both are turned off. This creates the initial set of data, and this goes ahead and updates the data as well. If we take a look at a query against that table, so if we do a select star from my puppy costume invoice fact 60, if you scan through there, you see that I have 2 months worth of data in this August and September data only. I want to go ahead and add October's data and delete my August data, therefore keeping just simply a rolling 2 months worth of data. I can do so, and this is going to be done manually, but you can think about how you could set this up to be automatically deleting your data before inserting the new month's worth of data. Keeps your data more crisp and clean as an ongoing basis. But again, this only works because I know how to do that delete statement. So I come back into my Alteryx workflow. We're going to turn on the delete. So the options that you have is both on the input widget and on the output widget. You have pre-SQL and post-SQL. What this means is that the pre-SQL command will be read before will be executed before the data begins to be loaded into, or as you move forward from your process. It allows you to go ahead and determine when you want to run that pre-SQL. What this says is as soon as it begins to think about this, it will run. Otherwise, it will run when the data begins to flow through it. I tend to leave that by default, but again, in this case, we're not doing anything before we do the query, but again, you can do this before the query runs or after the query runs in order to do some work. Give you the do some data management. These will be SQL statements that you have to type in that will execute properly. They are not validated when you create them, only when you execute them. What we'll really look at is with our data being inserted into this table, what we want to do is before the data is inserted, so a pre-create SQL statement, we want to go ahead and delete last month's worth of data. So on the input, we are reading in October's data, and before we insert that data into our table, we will delete August's data. So here is our delete statement as well. So we go ahead and run this very quickly. Didn't take very long to go. We can see that this is the data that was brought in. It's October's data that was brought in. We go ahead and take a look back at our data, execute the same query. We now have September and October data. The August data was deleted. So this is how you can build some of your data management into your Alteryx workflows. But again, it's up to you to understand how that command should be executed, how to document it and define it, and to test it outside of Alteryx before putting it into your Alteryx workflow. So let's talk about views. What is a view? It's a bit confusing to a lot of people. It's basically a very simple structure. What a view does is it instantiates a SQL query as a database object so that someone can reference that view and then the embedded SQL be executed for them so they don't have to worry about the complexity of a SQL query if it's having to join multiple tables or do some other very important operations such as inner joins, outer joins, right joins, left joins, etc. to get the data cleaned up and presented to a user. A lot of people do not like the data mart structure, which is the dimensional model, because what they say is, well, if I get to this data and understand what's in here, I have to join it to all these other tables, and I don't like writing that query that has all those joins in it. And to a degree, that is true. But when you build your data in this structure, it's a very efficient structure. It's a very accurate and resilient structure of information for you to report out of. So what you can do is to create a view that makes this overall structure be behind the scenes so the users of this data don't have to understand all that joining. So when I want to create a view, the first thing that I need to do is have a query that resolves the data the way I need it to. And if you're familiar with our multi-table join in the previous module that I had done, we created a view, something like a query, something like this. Let me drag this down to where what I was doing is querying data out of the puppy invoice fact. I was joining it to each of its dimensions, returning some of the column and attributes. If I was to make this a view, I would return a lot more of the attributes than I have here, just to make it more applicable to more people. But this was a query that we had done. We can execute this to verify that it works, and it does indeed work, and it returns that data. So what I want to do is to turn this into a view. So creating a view requires the create statement. It is basically create view. Give it a nice name so people know what it is. Just for consistency, I'm going to paste in the name that I was working on. This is the puppy costume invoice report object. I type in the keyword as, put an open parentheses in front of it. So it is create view, the name of the view as. There's my select statement that I know works. And then I close the parenthesis on the other side. Execute that. Very quickly, the create view worked, no errors. And now what I can do is, rather than this, I can do a select star from and delete all the rest of this. So that query into a single object, which is the view, will join all those tables together for me without me having to type in all the joins and return the data set that was predefined from within that view. When you run against this view, you can put any attributes in the select as well as any clauses after that, any where clause or order by clauses that you might need. It's also nice to say what about Alteryx in a view. Well, it's very easy. Alteryx can go ahead and use that view as well. All I've done here is I have my input data widget. It goes against that view as opposed to going against the tables and then join those tables outside or inside of that query. It's very straightforward with my select and my browse. We run that and that data is brought down very efficiently and I can see it in my browse. So my view is readily available to Alteryx in order for me to process and reduce the requirements for creating complex queries. Second thing you might want to do is you might want to alter the view if you don't like the way it looks. Need to make some changes to it. Go ahead and bring our view back the way it was. And what I want to do here is simply alter view. And rather than this being puppy name, let's call that as name. Execute this alter statement. It ran successfully. Now what I can do is to select star from the newly created or modified view. Oops. Too much editing, put the star in there. And now rather than puppy name, it's bow wow name. So you can alter the name of the columns that are being returned. That might make it more useful to the business. And finally, when I'm done with this, if I don't need that view anymore and cleaning it, I very simple have a drop view command. And that view is gone. There is a tab for views inside of the navigator. So if I did have these views, they would be there. Cool. Let's go ahead and create it again. View got created. Nothing got changed because it doesn't know that I executed that command. Hit my refresh. Minimize out my tables. You can see now when I expand out my views, that view is there. Expanding that out shows me the columns within that view. The last thing to talk about within this topic of views is documentation. If you have a very robust semantic layer, which is a combination of views that match the business needs so that your business community or yourself don't have to go through the complexity of joining tables or doing other work within the rows and columns that you need, it's good to be able to document that. A lot of RDBMSs allow you to create view comments as well as view column comments so that it can be easily documented for the business to see or for any users to see. However, that is not universally available across all RDBMSs, and I cannot show you that on the MySQL because the MySQL Community Edition does not allow me to create comments on the view or on the view columns. So the users would have to know information about the view to find any embedded documentation associated with the views and the tables within them. And that again leads to why you would, as a universal solution, want to look at building your own set of tables that manage the metadata and presents it through your favorite BI tool. So as a little bonus, if you've watched all the way through the end of this video, we'll talk a little bit about how you can get Alteryx to help you manage your database, doing some of the basic things in there if you wish to not have to learn or to always remember how to execute all those commands. You can use the Alteryx app functionality in order to do some of this management for you. Because you have your pre-SQL and your post-SQL both on input and on output, you can go ahead and use that to your benefit in creating some pretty slick little apps that will help you manage your data. But again, before embarking in building this app, one, be familiar with how apps work, and to a degree, if you really want to make this very robust, you're going to have to understand how to do chaining apps, which is a bit tougher to understand, but necessary to get the apps to really be dynamic. In this case, I created a very simple one. And then again, the third part of this is to go ahead and understand the SQL commands that you need to execute in the RDBMS, test them and feel comfortable with them, and then you can build an application to do this. So for this quick little example of an app, I've made a much more extensive one of this in the past. I've also allowed people to utilize apps to move data from one schema to another schema because they had to move their data for whatever reasons. It became pretty useful and very fun to do. But here, again, when you build an app, you start with something that actually works. And what I'm doing simply here is creating an input widget that will select all the record count from a table. I've done that by creating my query. And again, since this is an app, what I need to do is to create a stub of something that works in order to get the app to update it. So this is not very meaningful, but basically what I'm doing is selecting the name of the table and then a count from that table, and that will return me a count of the tables. And I want to go ahead then and delete that table after having counted the records, and then be able to show the user that this table had this many records, and then we went ahead and deleted it. Canceling that out. Where this work comes from is now here in my post SQL statement. So after this query runs, what I want to do is go ahead and drop the table that they've told me. This name that's put in here in the drop table is just really a stub, so that there's a command in there that I can then edit it with the app. Showing you a little bit more how the app works, what we're going to do is go ahead and allow the user to enter in the name of their table that needs to be dropped. This is the prompt that comes from the interface set of widgets that turn my workflow into an app. I'm going to ask them to enter the table to be dropped. The default text in there is my default schema, Daisy Hill dot, just for completeness and to show you how you would want to possibly flesh this out in the future. And then what I'm going to do is use the input that gave me in order to make two changes. So I have two actions coming from one input. The first action goes ahead and edits the name of the table that is inside of the select statement. So I've done that by choosing file or a value. I want to update a value. I choose replace a specific string, so update value, the actual line from the definition of that widget, and then I'm replacing the name TILDUAL, which is the stub name of a table, and I'm going to replace that string within this query statement, so then it will have the name of the table that you were provided through the input. The second action is a lot like the first action, because it's going to take that table name, and we're actually going to go down into format specifications and into my pre-SQL and update value, replace a specific string, and I replace the string that is in my drop table command, which is the post SQL, and replace it with the table name that came in. Putting all this together and making it work, what you will see is that if you have a remembrance that we had that table sitting out there, let's go ahead and drop one of the tables that I have defined inside of my MySQL database that we worked on today. I can run this either standalone by double clicking on the app name, or I can choose the magic wand. This brings up my question, which is to enter the table name. Daisy Hill's at the beginning of it. Makes it sort of easy for me just to go ahead and type in my InDB table that I had created. It's the fastest and easiest one for me to create, so I don't mind recreating it. Once I've typed in that name, I hit the finish button. It'll go against my database. It'll come back and say that there were 13,200 rows inside of this table. If you want to know whether it actually deleted or not, you can click on the show output log, and this will show you the log associated. Expand this out if I get it picked just right. This will go ahead and show me that it went ahead and read from that, and executed the post SQL of drop table daisyhill.puppy costume invoice fact underscore ndb was indeed executed for me. I can now click OK because I'm done looking at there, exit out of this app, come back into my MySQL workbench, hit the refresh button, and the NDB version of this table is now gone. So now you can begin to expand your mind, your methodology to see how it is that you might want to create apps to help you do some of the basic data management once you've learned the tools and the steps and the processes, and can make it sort of bulletproof or just use it to make your life a little bit easier. If you need more information on building any of these structures or any of the commands that we covered in today's little module, please subscribe, drop me a comment. I'll get back to and answer your comment and look on working with you or creating some additional workflows or information to help you with managing your data from the RDBMS level. Also, don't forget, I have backgrounds with SQL Server, Oracle, DB2, and Teradata. So if you have questions are specific about how to translate the MySQL commands into those RDBMSs, I can give you some guidance there as well. Thanks for watching.